Here we go. Okay. So, you know, again, I think with multiplying and dividing, all right, the key thing here is that you don't need common denominators. So, okay, which is huge. You can kind of like just jump right in if you want to, okay, to the multiplying and stuff like that. Okay. So we'll let's see. I don't want to do it go too crazy all at once there, but some of these are pretty nuts. Maybe I'll go here. No? Okay. All right, well, let's do this then. So, and also you may want to simplify or cancel first, then multiply or divide. Okay, so you may want to simplify or cancel out stuff first. You can, then multiply or divide. Okay, could be a good idea. Okay, so let's see here. We'll do this one first. So let's just do an example here. Let's say we want to take 3x minus 3x squared all over x squared plus 4x minus 5. And we're going to multiply that with x squared plus x minus 20 all over 3x. Like so. Okay. So, one option here is that we could just go ahead and just multiply, right? We could do, you know, this times this, and then this times this, right? So 3x, well, the 3x minus 3x squared, right? You'd have to like distribute to each one of these terms here, and then distribute 3x squared to each one of those three terms there as well. It's going to be a lot, right? Okay. Well, like I said, let's try and simplify or cancel things out first, maybe, and that can potentially help us out here. Okay, so in other words, we're going to hold off on multiplying here, and let's try and just factor this thing to see if we can maybe get some things to cancel out. So from my numerator here, what can we factor out? 3x, yeah. Okay, if I take a 3x out of 3x, I'm left with a 1. If I take a 3x out of 3x squared, I'm left with an x, or a minus x there. And immediately we can see, oh, there's going to be a 3x in my denominator there, so we'll be able to cancel those out eventually here. How about this quadratic? Does it factor? We're looking for two numbers that would multiply to make negative 5 and add to make positive 4 there. So two numbers that multiply to make negative 5 and add to make positive 4. Yeah, x plus 5, x minus 1. Okay. And then, let's see here. How about the next quadratic that we run across here? Right, it's this guy. All right, we're looking for two numbers that multiply to negative 20 but add to make positive 1. Yeah, positive 5, negative 4. Okay, all over then 3x. Okay. And so, do we see some things that can cancel out? Okay, right, the 3x's. In fact, I'll do this in a different color here. Yeah, so the 3x here and the 3x here. Okay? Now, this is not cross multiplication. Question, CJ? Right, good question. We'll get to that in just a second. Hold on, hold that thought. Yes, we'll get to that. So back to what my point here was, right? You might look at this and say, Mr. Witt, isn't this like cross multiplication? It's not cross multiplication, right? When we're multiplying, because we're not actually multiplying here, we're canceling out, right? The multiplication, again, is going to be across the top. All those things would multiply, and across the bottom. Since we're going to multiply all these things across the top together, the 3x in the numerator and the 3x in the denominator are going to eventually, combine together in one fraction, so we can cancel them out. That's what allows us to cancel those things out there. The 3x here in the numerator, the 3x here in the denominator will eventually share the same fraction, right? One will be in the numerator, one will be in the denominator, and so that's why we can cancel them out. Okay? What else can also cancel out here? The x plus 5s, right? Exactly right. Okay, so those cancel as well. Now, let's get to CJ's question. CJ asked, right, 1 minus x and x minus 1, those look awfully close to each other. Okay? Are they the same? Is x minus 1 the same thing as 1 minus x? Not in general, no. Okay? So we might think, oh, we can't cancel them out. So let me just pause on that. Let's go ahead and put these things together. So we have the 1 minus x still left up here. We have the x minus 4. Okay, over. And then what's left down here? Well, the only thing that's left is the x minus 1. Now, these things are very close to each other. Very close. All right? And in fact, we can get them to match up. Here's how we're going to do that. Factor a negative 1 out of this. Okay? Factor a negative 1 out of 1 minus x. So if I take a negative 1 out of it, what's 1 divided by a negative 1? What's 1 divided by negative 1? Negative 1. What's negative x divided by negative 1? Positive x. Okay, is negative 1 plus x the same thing as x minus 1? Is negative 1 plus x the same thing as x minus 1? They are the same. They are the same. So we can cancel these things out. Okay? And so what's left? Well, in the numerator, we're going to have the negative 1 times the x minus 4. What's still in the denominator? What's going to be in the denominator? Not 0, right? When we cancel, what number is left behind? A 1. So you can leave a 1 in the denominator if you want to, or we can just say negative 1 parentheses x minus 4. And that's our final answer. If you want to distribute the negative 1 through and make it negative x plus 4, feel free, but it's not necessary. You can leave it like that. Okay? So, I mean, I don't know. That's pretty satisfying, right? We go from this, like, crazy mess right here. We factor. Things cancel, right? And we get down to this, like, nice, more simplified version right there. Okay? Not too shabby. Okay? You're taking something that's, like, more messy and making it neat, right? So there's maybe a little bit of satisfaction with that. I don't know. All right. Let's try another one here. All right. Let's do All right, I'll pick another one here. All right, let's do x squared plus 3x minus 4 over x squared minus 49 times x squared minus 11x plus 28 over x squared minus 4x plus 3. Okay, lots of quadratics here. Okay. So all these quadratics, right, do any of them immediately cancel out here? No, unfortunately not. So we have to factor, right? All right, so first one here, we're looking for two numbers that multiply to negative 4 but add to make 3. Two numbers that multiply to make negative 4 but add to make a positive 3. Yeah, positive 4 and negative 1. Over. Okay, for this one, right, we're looking for two numbers that multiply to make negative 49 but add to make, well, there's no middle term, so we'd say 0 there. So multiply to negative 49 but add to make 0. Yeah, x plus 7, x minus 7, right? That's that difference of square right there, difference of squares. Okay. How about this one? Two numbers that multiply to 28 add to negative 11. Yep, 7 and 4. Minus 7, minus 4. Okay, and then denominator here, two numbers that multiply to 3 but add to make negative 4. Yeah, negative 3, negative 1. X minus 3, x minus 1. Okay. So if you're a little rusty in factoring, you're going to, we'll need to get you unrusty here because we are going to be factoring quadratics for sure. Okay. And again, if you really want to use the A times C method, you can, but it's not necessary here because the A is 1 for all of these, right? And so it's just going to be, we're multiplying to that C term and then adding to the middle term there. And then it just breaks down exactly as you see it there. Okay. If you have A other than 1, right, like we did in the warm-up, I think, right, then you'll have to be a little more careful. You'll have to use the A times C method and stuff. All right. Anyway, we've got it all factored now. Anything cancel? Here's the fun part, right? We get to get rid of stuff. So what cancels out? X minus 1 and x minus 1. Anything else? We got an x minus 7 and x minus 7, right? Anything else? No. Okay, and it's important to also understand when to stop canceling, right? So. There's our answer. If you want to multiply those two things back together, you're welcome to, but it's also okay to just leave it like that, I would say. Okay? We've multiplied it together there. We've answered the question. There's no more simplification we can do. All right? Ready to try one on your own now? Let's give you guys one to try here. Question? Yes. All right, so here's one for y'all to try. And then we'll do some division one too. All right, so again, simplify, or multiply / simplify. We'll say is the directions. Are the directions. Okay. 2x squared minus 10x all over x squared minus 25 times x plus 3 over 2x squared. Okay, try that one. See what you can do there. All right, let's go to someone who's here. Cheyenne. Cheyenne, were you able to simplify this at all here? Factor it at all before you multiplied it? Okay, what'd you factor that to be? Okay, x minus 5 times x plus 5. Okay. What about the numerator there? I see a GCF. What can we take out of that numerator? Yeah, 2x, right, okay. So if we take a 2x out of the 2x squared, what will be left behind? X. And take a 2x out of the minus 10x, we're left with a, minus 5. There we go. So that's going to be helpful too. Then we have the x plus 3 and the 2x squared. Okay, so, Cheyenne, now that we've got that all factored there, do you see anything that cancels before we multiply here? X minus 5s will cancel. Very good. Okay, does anything else cancel? Yeah. Okay, this 2 will cancel with the 2 here, and this x will cancel with the x squared. So the x here will completely cancel. This x squared will now just be x to the 1. Okay, and so what's going to be left in our numerator here to multiply together, Cheyenne? What's left over? Yeah, just the x plus 3. Very good. In our denominator, what's left over? We have the x to the 1, and then the x plus 5. Yeah, so we'll have the x times the x plus 5. And there's our simplified answer. Okay, that's the best we can do. Okay, good. Questions on that? All right, then let's take a look at division here real quick. We'll do 2 examples with that, and then I'll have you guys try one, and then we'll get into what I'll have you guys start on their homework and stuff. Okay, so, all right. Oh, sorry. Yes. Mr. Wood's too fast. Good? Okay. Anyone else still need it? Okay. So then, like I said, we'll talk about division here. Woo. So, with division, all right, the key thing here, wow. Change to multiply by the reciprocal. Okay, we don't do division. Okay, really we don't. You can kind of divide fractions if you want to. I mean, like for example, if you have 15 fourths and you want to divide that by like 3 halves. Okay, so I mean you can divide fractions. All right. So for example, like I said here, 15 fourths divided by 3 halves. You can divide fractions just like you multiply. What I mean is, when we multiply, you multiply across the top, you multiply across the bottom. You can divide fractions by dividing across the top and dividing across the bottom. It's just that it's rare that the numerators divide nicely and the denominators divide nicely, and you end up with a nice fraction at the end. But in this case, I set it up in such a way that it would work out nicely, right? What is 15 divided by 3? 5, right? What is 4 divided by 2? 2. So we get 5 halves. And if you don't believe me, right, you're like, wait a minute, Mr. Wade, are you sure about that? Well, let's change the division to multiplication, right? Multiply by the reciprocal here. Okay? 15 fourths divided by 3 halves, the same thing as 15 fourths times 2 thirds, right? 2 over 3. And we multiply here, we get 30 over 12. But 30 over 12, let's see, we can divide both of those by 6. Right, 30 divided by 6 is 5, 12 divided by 6 is 2, and well, there's your 5 halves that we had earlier. So you can divide fractions just like we multiply. Divide across the top, divide across the bottom. It's just that it's rare that the numbers work out nicely. So we generally don't. We just change it to multiplication. Okay, so back to an example here then. Okay. Let's just do one. So let's say we've got 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. So first things first here, change that division to multiplication by the reciprocal. So instead of dividing by this, we will multiply by the reciprocal. So we'll put the x squared minus 11x plus 30 in the numerator, and the x squared minus 6x in the denominator. Okay. And now let's factor, right? So 7x doesn't really factor anymore, so we'll leave that. 2x minus 10, what can we factor out of there? 2. So we're left with an x minus 5. Okay, and we're looking to factor our quadratic here. We'll need two numbers that multiply to positive 30 but add to make negative 11. Yeah, so 6 and 5, so negative 6, negative 5, yeah. Okay, they add to make negative 11, they'll multiply to positive 30. And then x squared minus 6x, what can we factor here? What can we take out? An x. We're left with an x minus 6. Okay. Alrighty, so what cancels? X minus 5s. What else? X minus 6. What else? Not it. The x. Yeah, don't miss the little x there. Okay. So goodness gracious, all that cancels out. What's left? What do we have at the end here? 7 halves. 7 over 2. Okay. 7 over 2. That simplified very nicely. Very nicely. What happened to the x? Why did it cancel? Well, we had an 7x up there. We had the x times x minus 6 there. So the x was going to, again, it would be all the way one big product here. So this x and the x down here will also be a part of one big product. So the x's can just cancel out, right? You have an x divided by an x. They cancel out. Make 1. Okay. All right, one more here, and I'll have you guys try one. 6x squared plus x minus 15 over 4x squared divided by 3x squared plus 5x. All right, so again here, right, we want to change that division to multiplication by the reciprocal. So instead of dividing by this, well, I'll rewrite it here. 6x squared plus x minus 15 over 4x squared. Instead of dividing, we'll change it to multiplication. But what's the reciprocal of 3x squared plus 5x? 1 over 3x squared plus 5x. Exactly right. Okay, so we can imagine this is really over 1, right? So when we reciprocate it, we're going to have 1 over 3x squared plus 5x. The whole thing goes in the denominator. Okay, and now we will factor. Now, to factor this, right, to factor this, we are going to need to use that A times C method. So 6 times negative 15 is going to give me negative, oh goodness, 60? No, negative 30. No, 90. Goodness gracious. Negative 90, all right? And so we're looking for two numbers that multiply to make negative 90 but add to make positive 1. So again, 6 times negative 15 here gives us that negative 90. And we need two numbers that multiply to make negative 90 but add to make positive 1. Well, what are two numbers that multiply to make negative 90? Okay, 1 and negative 90, but they're not going to add to make 1, so that won't work. What else multiplies to make negative 90? Okay, negative 30 and 3, they multiply, but they won't add to make 1. Or negative 3 and positive, yeah, negative 3 and positive 30 or positive 30 here. Negative 30 and positive 3. What else? There you go, 10 and 9, yeah, okay. So positive 10, negative 9, right? So let's see here. I'm going to have to do this. I'll do this over here. Whoops. Hello? Hi. What's up, Miss Harrison? I am well. What's up? Yes. Oh no, I said something. I sent something to Shelly about it yesterday, and she said she had taken care of it or something like that. So. Oh. Yeah. Yes. Yeah. No problem. Not a problem. All right. Bye. Okay. All right. Anywho, so let's see here. Right. Okay. So we're going to break this up here. So it's 6x squared plus 6x minus 15x minus 15. Okay. So again, we're going to factor that quadratic there. So let's zoom in on that real quick. So from here we can take out a 6x, leaving behind an x plus 1. And from here we can take out a negative 15, leaving behind an x plus 1. And so it's going to be 6x minus 15 times x plus 1 when we factor out there. Okay? So, and then we'll have the 1 there. And then 3x squared plus 5x, what can we take out from the 3x squared plus 5x? Okay, we can take out a what? A 3 and an x? Does 5 divide by 3 evenly? No, so what's the most we can take out from this group right here? An x, okay? So we've got x and then 3x plus 5. Well, shoot. Nothing cancels. Nothing cancels here. Okay. Let me see if I made a mistake here somewhere. Say it one more time. 10 and 9. Oh, and I did like... Yeah, what am I thinking here? Sorry. Thank you. Wow. Okay. So, yes, sorry, it was 10 and 9. Yes, thank you. Why did I do that? I guess, yeah, well, anyway, I know what I did. I looked at the A and the C, and I just did it from there. So, my mistake. Sorry about that, folks. I went completely off the rails there. So, plus 10x minus 9x minus 15, like that. Okay, that's how you're supposed to break it up, using the 10 and the negative 9. Yeah, so, okay, sorry. We can pull out a 2x from there, leaving behind 3x plus 5, and plot a negative 3 there, leaving behind a 3x plus 5. There we go, 3x plus 5, 2x minus 3 is how it really factors. So that was way off. Okay, there we go. Sorry about that, folks. Okay. Now, what cancels? The 3x plus 5s too, right? Okay. So that's all though, right? That's all that cancels. The 2x minus 3 then is still going to be left in the numerator. And then in the denominator we have 4x squared and the x to make 4x to the third. Okay, to make the 4x to the third there. All right. Questions on that? All right. So what I think I'm going to do then is rather than give you guys one to practice, I'm just going to go ahead and give you guys your assignments. That way you can just get that started on and stuff like that. Okay? So... let me give that to you here. All right, so it's going to be out of the book. I'm also going to give you one graphing one as well for some practice here too. Okay. This will be page 446. Not 446, sorry, I have to look that up actually. It'll be section 9.2. look that up in the actual book here. Okay, 9-2 is, the homework's on page 323. Okay, and here's what I will have y'all do. Let's have you do 3 to 13, the odds, and 14 and 15. Okay, so 3 to 13 the odds, and then 14 to 15. Okay, 14 and 15. And then let's see, here's what I want to give one graph. Yeah, I'll do that too. I'm also going to give you one graph just to make sure we're staying up on top of things here. So I'm also going to have you graph f of x. This is just to keep our rational function stuff fresh. Okay. Going to have you graph 2 over x plus 1 minus 2, like that. Okay. So identify domain. Any holes or vertical asymptotes, any horizontal asymptotes or slant asymptotes, okay, and any zeros as well. And of course then graph it. Well, like it says here, but you get the idea. Okay. So this one as well, please. Okay. Make sure you can do that too. Okay.
This or the bigger the better.
Yes. So go ahead and get started on that. I'll come around and help here as soon as I get this video compiling.